Alright, so good morning everyone. We are going to be looking at your chapter 12, section 5 notes for today. We're going to be talking about similar figures. So similar figures are actually when we start to involve size changes with our figures, and we kind of look at both the end and the beginning together. We don't necessarily know which one we started with, which one we ended with. We just have these two shapes. We know there's some sort of size change between them, but we want to work with them. So we're going to go ahead and start by kind of defining what similar is, talk about what it actually tells us, get another vocab word, and then do a couple practice problems. So let's go ahead and get started. So first of all, we have similar. The big thing here is we have this symbol here. That is our symbol for similar. So it's just a nice little squiggle line. If you remember, that's also used in our congruent symbol. In our congruent symbol, though, we put it on top of our equal sign. We'll talk about why that is here in just a second. Okay. But first of all, in order for something to be similar, we're going to say that two figures are similar so we're assuming that we have two similar figures. If they are, then we can say that they are similar if they are transformations of each other. Now, that transformations, that comes back actually from first semester. We talked about what our transformations were, but we actually have a new one now. So we have our size change. That's the one we've been talking about recently. But we also have all of those isometries. So we can have either a size change, or we could have an isometry, or we could have some sort of combination of both. Okay, so we have either a size change or an isometry. Now, hopefully, you're remembering what your isometries are. If not, I'm going to list them over here off to the side just so we remember what they were. So we had reflections, we had rotations, we have translations, and we have glide reflections. Any one of those four could be involved in our size change, or in our similar figures. I'm going to go ahead and pull this up so it's a little easier to read. So here's that definition again. So two figures are similar if they are transformations of each other. So if I can do one of these five things, either size change, or reflection, rotation, translation, or glide reflection, and I can get from one shape to the other, going either direction, then the figures are similar. Okay, so let's talk about what that actually tells us. So our similar figures theorem is really going to be the one that we want to work with most often. This one is actually assuming that we're starting with similar figures, and then kind of what do we get if we know they're similar. So we're going to start by making that assumption. We're going to say if two figures are similar, then, and this is where we have the two options here, so we actually get two different things out of this theorem. We got one thing dealing with the angles and one thing's dealing with the size change, or with the sides. So if we remember back to all of these transformations, we said that they all preserve at least A, B, C, and D. That was angle measures between this collinearity and distance. Orientation was on some of them, but not all of them, so we're going to ignore orientation for now. And we recently said that size change is A, B, C, and then D is proportional. So really what we're looking at are those same things. Now the one that's really important for us is the fact that we have A's in both of these. A's went with angles. So we can actually say that the angle measures, or if these two figures are similar, then their angle measures, or angles, are congruent. Okay? So our angle measures have to be congruent. The other one we always like to talk about is the sides. So if we go to our isometries, we know the distance stays the same. That was congruent. But here our distance we said was proportional. So that's kind of the weaker of those two statements. So that's the only one we can really say. We can't say that they're always going to be equal. They might be, but they might not always be either. And so that's why we're going to say that their distances, or their sides, which is really referring to those distances, are proportional. So proportional meaning that I could write them in a proportion, which is helpful for us because we know how to solve proportions. So if I have a missing piece in that proportion, we can actually find an answer. Okay. Real quick, before I go any further, I want to talk about that symbol I put up here at the top. So we talked about congruent versus similar. And we have kind of this similar symbol inside our congruent symbol. Really, the only extra piece there is that equal sign underneath. So what congruent actually means is that they are similar and equal depending on what thing we're talking about. Could be shapes, could be just parts of things, but it means that they're similar and equal. So we actually combine those two symbols to get congruent. We didn't necessarily break this apart earlier because it's easier just to think of congruent as they're exactly the same. So when we're similar, we know the angles measures are the same, but the sides are proportional. But this equal part actually trumps over this proportional part and says that the sides are equal too. So this gets us back to our regular kind of congruent definition. So that's just kind of a review back to congruent. You don't necessarily need to know that's how we get the symbol. It's just a good thing to kind of make that connection. Okay. Last vocab word we have here is what we call the ratio of similitude. It's kind of a fun word to say. We're going to use this a lot in our next section, which is the 12.6 and 12.7 section. We'll be talking about that one a lot next week. So we'll use this ratio quite a bit. But we first need to know what it is. So the ratio is referring always to a fraction. So we're doing some sort of comparison using a fraction. And similitude is really referring to that similarity. So how are those sides related to each other? So we're really looking at sides here, the lengths of those sides. So we're going to say that the ratio of similitude is a comparison using a fraction of corresponding lengths. And those lengths are really referring to sides. That's what we're talking about there. Okay? Now, the weird thing with ratio of similitude is that seems like it should just be one thing, but we're actually always going to have two ratios. Those two possibilities come from our two different directions that we could go with our size change or between our similar figures. So we're going to have two possible ratios. And the way we can kind of think of it is we're always going to have one shape that's bigger and one shape that's smaller. So when we start with the smaller one, we're going to be doing an expansion, or we're going to expand. And so the ratio there is going to make things bigger. But I could also flip the way I'm thinking about things and start with the bigger one and go to the smaller one. That's going to then be a contraction, okay? Or we're going to contract, okay? So those two ratios are really just distinguishing between when we're expanding and when we're going to actually contract with our figures, okay? We've actually talked about this thing before. We just didn't give it this name, the ratio of similitude. We called it before, I'm going to put AKA over here, we called it magnitude. Spell that right. Magnitude. Okay, so magnitude was what we called it before. Now, there's actually another way that we kind of refer to it. We a lot of times referred to it as like our K value, which is really looking at how is that size change kind of playing out. What's the factor of that size change? What are we multiplying by? So you can refer to it as the magnitude, the K value, the size change factor, or the ratio of similitude. They're all getting at that same thing. What are we multiplying our side lengths by to get our next shape? Is it getting bigger? Is it getting smaller? What does that number have to be? Okay, so that's our ratio of similitude. Keep that one in the back of your mind. You're not going to use it a whole lot here today, but we will be using it a lot more moving forward. I believe it does show up on your homework as well, that definition. So make sure you have that one written down. Okay. So for number one here, we're going to go ahead and do our two examples. Number one is saying that we have A, B, C, D, and W, X, Y, Z. Now we have four letters there, so we're talking about some sort of quadrilateral. I don't actually know what this shape is, so it's not like I can draw a picture here. It could be a square, it could be a trapezoid, it could be a kite, it could just be a quadrilateral. That it doesn't really fall into one of our other shapes. So we're just going to go ahead and not draw the picture. We're just going to kind of think about how these things line up and what this statement actually tells us. So a couple things here. We have the symbol in between. Hopefully you recognize that symbol at this point. That is our similar symbol. So this is saying that A, B, C, D is similar to W, X, Y, Z. And this statement is pretty powerful for us. This is kind of similar to our congruent statements that we use first semester. The order of the letters here are going to match up with the orders of our second figure. So if I want to look at corresponding angles, A is going to correspond to W, B corresponds to X, C to Y, and D to Z. They all match up with each other exactly in the order that they're listed out. Okay? The second part here is actually really helpful for us too. It says ABCD is the image of WXYZ. So if it's the image, that means ABCD is actually our new shape. We were starting with our old shape of WXYZ. Okay? So if I want to go from WXYZ to ABCD, I'm going to follow my size change. And here we're told that it's S2. That means our K value here is really 2. And that K value, again, is that ratio of similitude. Okay? So we're looking at that ratio there. Then we're told if M, or the measure of angle B, is equal to 85, then BC is 12.1 and AD is 4.2. We're going to find any other angles or sides that we can. So let's start with the angles because those are a little bit easier. If we go back up to our theorem here, it says that angles are congruent if my shapes are similar. Well, we know the shapes are similar based on this statement. So I can go ahead and say that my angles are congruent. So I know I'm going to have another angle here that's equal to 85. So I have some sort of angle that's going to be 85 degrees. Now the question is, which angle is it? Because I got 4 options. This is in our kind of new shape. That's angle B. So if I look here, angle B is in that second spot. It's kind of our second letter that's listed there. So I need to pick the second letter that's listed in our second one, which is X. So we're going to say that angle X is our angle that is 85 degrees. Okay, so that's our first one. Next, we can move on to our sides. Let's just go in order here. We have BC. So I have BC is equal to 12.2. So I need to start by looking at BC. Well, BC is in my new shape. That's kind of those middle 2 letters. So if I want to look at BC, BC is going to match up with the middle 2 letters of our second shape, which is going to be X and Y. So I know BC is going to help me find XY. I just got to figure out the way that I do that. So this is where we got to pay attention to our K value. This K value is going to make things bigger. Okay? And if I look right now, I'm going from my original shape was the WXYZ and going to ABCD. Okay? So that's the way I need to use the 2. It's just going straight forward. I can multiply by the 2 on any of these values in WXYZ to get ABCD. But I'm actually going backwards here. I know BC is going to be 12.1. I want to know what XY is that goes with that. So I actually need to do the reverse of multiplying by K, which means I'm going to divide. So I'm going to divide by that K value. So I'm going to do 12.2 or 12.1 divided by 2, which is going to end up giving me 6.05. So that's going to be my XY measurement. So I'm going to go ahead and list that over here on the side just so I have all my answers together. So our XY is going to be 6.05. Try that again, 6.05. Okay, so that's going to be XY. Now I can do the same thing with AD as well. AD is going to be 4.2, so I need to figure out what's the side that's going to correspond with AD. Well, that's going to be kind of my other 2 letters, really. It's kind of my outside pair here. So that's going to end up giving me WZ. If I look again, I'm going that same direction I did before. I'm starting with the ABCD shape and going to the WXYZ. So I'm going to go ahead and do the same thing I did before by dividing, but now I'm using the 4.2. So I take 4.2, divide it by 2, gives us 2.1. So again, I'm going to list that over here on the side. WZ is equal to 2.1. Okay, and that's actually all we can find because I've used all the information that I have. We know that there should be 4 sides here, but I don't know anything about any of those other sides, so I'm not going to be able to have a place to start. So we're just stuck. That's all we can find. So those 3 measurements are all we can use. Okay. Let's go down to number 2 here. Number 2 is where things are going to start to get a little bit different for us. So if you look back to number 1, we still knew our K value, and we were able to kind of work backwards and use that K value to help us out. Kind of similar to what we were doing before. If we look at number 2, we're not going to have that K value. Okay. All I'm told here is that ABC is similar to RST. Okay. Beyond that, I don't really have anything else. I have these 2 pictures, but I don't have anything about which one I'm starting with, which one I'm going to. I don't know any of that. And so when I start to look at these, I got to keep that in mind that I don't know if I'm going from the bigger one to the smaller one or the smaller one to the bigger one. And we can't really make an assumption either way. We have to just say that it could really go either way, and we have to not use one direction over the other. Okay? So we have some information labeled here in ABC. We want to find as many angle measures and lengths as we can in RST. So we're trying to kind of get some some numbers out of this RST here. Okay. First of all, I just want to label which angles here are corresponding because it's a little bit weird how they went from these shapes. So I know angle A is my first letter. If I look at my statement up here, R is that first letter too. So angle A and angle R are going to match up. I'm going to use my colors here to kind of distinguish this. B up top is going to match up with S, so that's over here on the side. And then C is going to match up with our last letter, which is going to be T. So it looks like we've kind of rotated this thing. We've also done a reflection, and then we probably have a size change in there too. So there's lots of different stuff going on with this one. But we know they're similar. That's the important part. We know they're similar. So let's start by looking at some angles. Angles are always the easiest, so I typically start with the angles. I only have one angle to start with, so I'm going to only be able to find one angle, and that's angle A. So So I need to figure out what angle corresponds with A. Well, I just kind of figured that out by labeling my vertices. So angle R is going to match that, so that has to be 56 degrees as well. So off to the side, we're just going to say angle R is going to equal 56 degrees as well. Okay? And that's angle measures. I don't have any others. If I had a second one, we could actually find a third one, knowing that they add up to be 180. But without knowing either of these other two, I can't really do anything. This one looks like it might be a 90, but I can't assume that. So we're just going to go ahead and not worry about the other angles. Okay? Last thing I need to check for is actually if I can find any other sides. So right now I have two sides in one triangle and I have one side in the other. That tells me I should be able to find one more. I should be able to figure out what's the corresponding one that I'm missing. So first thing I got to figure out is, do I have a pair of sides where I know or corresponding sides where I know the length in one shape and in the other. So I need those both corresponding lengths. If I look here, I think if I use the 30 is on AB, so kind of going between the red and the blue here, and that's going to match my 22 that I have on the other side. So 30 and 22 are going to go together. I don't necessarily know what order they're going to go in, but I know those are paired up. Then I have the 20, which is over here on the red and the green, which is on AB. That's going to match up with RS. I'm going to go ahead and call that X. So I'm going to try and find that side RS. Right? So let's go ahead and see if we can find that side. If we go back up to the top again, if we're working at sides, we know we have similar figures. Those are going to be proportional. So I'm going to have to use a proportion here. I don't know my K value, so I'm not going to be able to use a K value. I just got to set up this proportion and see if it gives me a missing side that makes sense. Okay? So let's go ahead and try this. I know I have two sides that match up, so I'm going to go ahead and put those in one fraction. I'm going to go ahead and just throw the 22 in the top. You can actually switch that. You could put the 30 in the top and the 22 on bottom. It doesn't matter as long as I match it when I go to my second fraction. So when I go to the second fraction, if I look, the 22 was paired up in this triangle RST. So I'm going to go ahead and use that measurement, which the second one I want to use is the X. And then again, if I come back to my ABC triangle, that's the 20. I'm going to put that on the bottom. Okay. And at this point, it becomes simply a cross multiplication. So we're going to do 22 times 20. That's going to give me 440 is equal to 30 times x. 30x. To get x by itself, I'm going to go ahead and divide by 30. When I divide by 30 on the other side, I'm going to get my x value by itself. So if I real quick, I have a calculator sitting here, I'm going to do 440 divided by 30. And I got 14.6 repeating. So we'll go ahead and call that 14.67. Just go a couple decimal places so that we know that that's a rounded answer. Okay, so we're going to call it 14.67. That's our missing side. So that's this side here, RS. So off to the side, I'll say that RS is 14.67. And I don't know the measurements there. I don't know what units there. Okay, so that's going to be our notes for today. You do have an assignment. It is in your homework packet. You're looking at Lesson Master 12.5b. So go ahead and take a look at that. We will be checking that tomorrow. So make sure that you have that finished and get that work done. You have plenty of time here in class. You can get started on it and try and get that finished in class.